Surface area and volume is one chapter where I do see some mixed opinion from different students. Some students find it easy because it is just formulas that they have and they just have to replace the values of those formulas in the problem statement. And it's easy to solve, either find the volume or the surface areas. There's another set of students who find it complicated because they do not know which formula to use where. When you have a combination of a cylinder and a pipe and a sphere and a cuboid, when there is too many elements involved, then it becomes a little complex for them to visualize how exactly should the final element or the final group of elements be, so that they can then start using the formula. But even when we have to use the formula, sometimes it becomes tricky when it is not the volume or the area that is being asked. You might have a pipe through which water is flowing at a particular speed, say 100 meters per second. And that pipe is now being placed inside a cylinder, a big cylinder, and the responsibility of the pipe is to fill the cylinder with water. So if the water in the pipe is flowing at a particular speed, how long will it take for the cylinder to be completely filled with water? So when these kind of questions are asked, there is a little bit of confusion or a lack of clarity that I see in most of the students. Because now we have a new component here, velocity or the speed, which is not there at all in surface area and volumes. So when you have this additional velocity component, how do we solve this problem? So that is what we are going to solve in this particular video, and do stay till the very end, because I'll also be sharing a few additional questions for you as practice so that you get comfortable with speed as well. Right? Okay, now let's get into the problem statement straight away. Water flows through a cylindrical pipe of internal diameters 2 centimeter into a cylindrical tank of base radius 40 centimeters at the rate of 0.4 meters per second. Determine the rise in the tank's water level in half an hour. So there is a time element involved and there is a speed element involved. So two new things in surface area and volume. But before that, let's again read the question. Water flows through a cylindrical pipe of internal diameters 2 centimeters. So there is one pipe which is cylindrical and there is a tank which is also cylindrical. So we have two cylinders, two cylindrical components here. One 40 centimeters and the other one, the diameter is 2 centimeters here. So it is, radius is 1 centimeter. All right. Now, if we draw the two shapes here, this is how it would look like. We have the cylinder, which is 40 centimeters, and then we have the pipe. The diameter is 2 centimeters, so the radius is 1 centimeter here. So water is flowing through this pipe into the cylinder. Now the question here is, how much of the cylinder will be filled in half an hour? So in half an hour, it could fill maybe some distance, some height here. We need to find that height. That is what the question is. So I hope the question is clear. Let me just repeat. Water is flowing through this pipe into the cylinder. This is the rate at which the water is flowing through the pipe, 0.4 meters per second. Determine the rise in the tank's water level in half an hour. So in half an hour, what is the height at which the water level will increase in this tank? Assuming the tank has no water at all, it is completely empty. Now we are filling water through this pipe for half an hour. So in half an hour, what will be the height of the water? Up to what level will the cylinder be filled with water? So that is what the question is. I hope the question is clear. Now let's get into the problem solving mode. So the volume of this cylinder, how do you find the volume of the cylinder? We do not know the height of the cylinder, but what we do know is it is 0.4 meters per second is the rate at which it flows. So every second there is a zero point 0.4 meter flow through this pipe, 40 centimeters. Okay, now let's try to calculate the volume of this pipe over here first. So we need to find out what will be the volume of the pipe in half an hour. So what will be the volume of water that will be flowing through the pipe in half an hour? And volume of the pipe, which is cylindrical in shape, is given by pi r square h. And radius, what is the radius? We know the diameter is 2 centimeters. So the radius is 1. Pi into 1 square into, now if you have to find the height, in this case, since it is mentioned that water is flowing at 0.4 meters per second. So volume of pipe, I would rather reframe it as volume of water flowing through the pipe in 1 second. So it is not volume of the pipe, it is volume of water flowing through the pipe in 1 second. This, let me reiterate the formula, pi r square h. So pi remains as it is, r square is 1 square into height. Height is 0.4 meters. So it is flowing. So it's like in 1 second, supposing this is 0.4 meters, right? 0.4 meters. So in 1 second, this much water is flowing through the pipe. We can assume or we can imagine it from that perspective. It's not exactly what I'm showing here, but yeah, we can imagine it this way. So in every 1 second, there is almost 0.4 meters of water, 0.4 meter distance that it covers, the water covers. So 0.4 meters in every second. So this is 1 second. And again, the next second, again, it covers another 0.4 meters. So every second, it covers 0.4 meter distance in that small pipe. So the height here is 0.4. So this volume, which is 0.4 pi centimeter cube. Now, one thing to note here. So the rate or the speed at which it covers is 0.4 meters per second. And we have the other dimension in centimeters. So we have to convert everything into one single unit. So here we have to convert 0.4 meters into centimeters. And how do we do that? 0.4 into 100, right? 1 meter equal to 100 centimeters. So 0.4 into 100 centimeter per second, which is 40 centimeters per second would be the rate at which it will be flowing. So this I have to multiply here by 10. So this is as good as 0.4 into 10, which is, sorry, 0.4 into 40. I'm sorry, 0.4 pi is 40 pi centimeters per second. So centimeter cube per second. So this is the volume that passes through the pipe, volume of water that passes through the pipe every second, 40 pi centimeter cube. Now where is this water falling? Into the cylinder, into this particular cylinder or this particular tank. And the final question that is asked is, what is the height up to which the tank is filled? Let us assume this is the height. So in half an hour, this much amount of water is filled in the tank. So effectively, we are trying to just equate the volume of the pipe and the volume of the tank. Volume of the water that flows through the pipe in half an hour is the same as the volume of the tank. Volume, the height up to which the water is filled in the tank. And the volume of the tank, volume of the tank is equal to, once again, it is pi r square h. We use the same formula. except that here the radius is different. Here it is pi into radius of the tank is 40 centimeters square. So 40 square into, and what is the height? We need to find that height. Correct? So this is the volume. Now this is the volume of the pipe that water is flowing every second, and this is the volume of the tank. Now if we equate these two equations, 40 pi equal to pi into 40 square into h. Okay, now we have equated this, but there's one thing that is still missing. So when we are saying height here, the height is actually in 30 seconds. 30 minutes. So when we are saying height here, it actually means the height of water content in this tank that gets filled in 30 minutes. So 30 minutes is what this water flows through this pipe. So for every second, we have 40 pi water flowing through this pipe, right? So if we have to convert this into 30 minutes, so 1 second, it is 40 pi. In every second, we have 40 pi centimeter cube of water flowing through the pipe. So if we have to find that for 30 minutes, then we have to multiply it by 40 pi into 30. But when we multiply it by 30, we are converting that into minutes. So if we have to convert, so when we are multiplying it by 30, we are just having that value in minutes. We have to have that value in seconds. So we have to multiply it by 40 pi into 30 into 60, because 1 minute is 60 seconds. So 30 minutes is 30 into 60 seconds. So this would be the volume of the water flowing through the pipe in 30 minutes. Volume of the water flowing through this pipe in 30 minutes. So if I put the into 30 into 60 over here, this will now be the volume of the water flowing through the pipe in half an hour. So volume of the water flowing through the pipe in half an hour is equal to the volume that gets filled in the tank in half an hour. This volume we know. This volume, the only thing that we not know here is height of the tank. So that is what we have to find using this formula. So pi and pi cancels out. 40, so h is equal to 30 into 60 into 40 divided by 40 into 40. 40 square, I'm just breaking it up so that I can cancel 140 out here. Then 1 0 of this cancels out over here. Then 4 15s are. So this comes to 3 into 15, which is 45 meters. So in 30 minutes, the height of the tank would be 45 meters. This is 45, centimeters. Right? Because we have converted everything into centimeters. So it will be 45 centimeters is what the height of the tank would be after half an hour when the water flows through the pipe. Alright, this looked a little exhaustive. So I hope you got the gist of it. Whenever we have the time and speed given in these kind of questions, surface area and volume related questions, I hope you got an idea of how we can solve this problem, right? So just as a practice, like I promised in the beginning of the video, I'll give you 3 questions that you can try and practice at your end, and I'll be sharing that in this last slide, so you can just try them out. And in case you are struggling, if you find it difficult, these 3 questions, do post your concerns in the comment section. So if required, I can create a video on these 3 questions as well. All right. I hope you found this tutorial useful. Please do subscribe to my channel if you're finding this content useful. And For any questions on any other chapters or any other topic or any other concept in maths, also please post in the comment section. I'll try to create a video and simplify that. All right, let's catch up in another video solving another problem statement in maths. Have a great day. Bye.